If I ask you to verify in grade 10 or grade 9 or whatever, and you had like 4x, everyone's just watching, 4x plus 6 equals 8, then you subtracted the 6, and you get 4x equals 2, and you divide by 4, and then you get x equals a half. Then you had to verify it or check it. Everyone's paying attention? For proper 30-1 format, you guys can make a little table like this, and you can go LS, RS, left side, right side. You're just paying attention, you're not doing anything. On the left side, you put the left-sided stuff. On the right side, you put the right-sided stuff. Anything on the left has to stay on the left, anything on the right has to stay on the right. Like you don't get to go over that line. That line's like a little zapping hole. You get zapped if you cross it. So your first step is to plug in what you have, right? 4 times a half plus 6. And then we would get 2 plus 6. And this equals this, right? And then it equals 8. Now do they equal?
Yeah.
So LS equals RS and you'd be done. Left side equals right side, and we know we're right. Because we got the answer, we verified it. Correct? We're doing that today with trig. So here you are in your notes package. Very top of the one I just gave you. So how do we verify? Everyone has to pay attention because you guys are kind of okay with verifying, except a lot of the time you guys stink at fractions. So that's where you get yourself in verifying. But you're also good at verifying until I teach proving, and then you kind of prove, verify together, and you wreck both proving and you wreck both verifying. You can't do either. So let's just focus on verifying being one thing. So the first thing we do is we make ourselves a T2. We put LS on the top and RS on the top, and those are the only things we're allowed to short form in all of Math 30-1, so enjoy it. LS, RS, that is it. Because in the math textbooks, LS is left side, RS represents right side, so we're allowed to short form it. That is it. Now, our first step for verifying should be rewriting that equation in here. So what we're doing is we're verifying that if I put 60 degrees into this, left side will equal right side. That's what we're verifying. Okay? We're verifying if someone went and solved it out and they got theta equals 60, we're now doing that last step to verify that left side equals right side. Do you know what I'm saying? So in the other one, I solved for x. We agree? This one, they're saying someone solved for theta, they got it at 60 degrees, verify that it actually works. So we're just doing that last extra step to verify that it actually works. Okay? So our first step is going to be filling 60 into the left side and filling 60 into the right side in this table. So we're going to go secant 60 degrees. And then we're going to get tan of 60 degrees over sine of 60 degrees. So the first step is to substitute theta in. Everyone's paying attention? First step is to substitute theta in. Okay? That is the absolute first step. People get verifying wrong on the diploma and on the unit test all the time because they don't follow the proper steps. So first step is substitute theta in. Second step is to put in answers to trig ratios. It's not to go to our formula sheet, it's to put in answers for trig ratios. So off to the side, I'm going to find out the answer to all of those trig ratios so I can put answers in. Okay? I'm not going to switch secant to 1 over cos. I'm not doing any of that. I'm going to go off to the side and find those 3 trig ratios and then put the answers in. Okay? That's second step. So off to the side, I have to find the answer to secant of 60 degrees. I need to find the answer to tan of 60 degrees. And I need to find the answer to sine of 60 degrees so that I can plug them in. So this is where our unit circle comes in handy, correct? And our formula sheet. But we need to find those 3 things out so that my next step has just answers in it. Do you see that? So secant of 60, what do we say? Secant of 60 is the reciprocal trig answer to cos of 60. Reciprocal trig ratio. So it is going to be the flip of cos. So what is cos at 60? A half. So what is secant of 60? 2. Cool. We're done the first one. Okay, we want to do tan of 60. Tan of 60 is harder to do, but we have a formula on our formula sheet for tan of 60. Because remember, on our unit circle, we have sines and coses. So secant and cosecant are just the flips of those. Tan and cotan, you fill the formula to get the sine and cos. So tan, the very two top formulas, below the theta, tan is sine over cos. So tan of 60 equals sine of 60 divided by cos of 60. I don't know why I'm writing sideways. What is sine of 60? Root 3 over 2 over, what's cos of 60? A half, correct? What did I tell you? If the denominators in both, back. If the denominators in both are 2, we can cancel them off, correct? And then I'm left with root 3 over 1, which is just the same as root 3. So now I know tan of 60 is root 3. Do you see that? Then I have the answer to that one. Everyone agree? Now the only thing I have left is sine of 60. What's the answer to sine of 60? Root 3 over 2. So off to the side, I do all of the math to get the answers to those trig ratios. Do you see it? I don't do the work in my actual verification. I do it off to the side. Do you agree? Everyone see that? That's the error that happens. People start trying to do the work in here. Verification, your first step is to plug in the answer. Your second step is to go off to the side and get the answers to those things. So secant of 60 equals 2. Okay? Then over here we put our answers too. Tan of 60 over sine of 60 equals, tan of 60 is root 3. We can put it over 1 if we want. Divided by sine of 60, root 3 over 2. So what can cancel? Root 3's, but we're still left with 1's up there, correct? So this is technically 1 over 1 divided by a half. What happens when you divide by a half? It flips, right? We could write this if we want to as 1 divided by a half, which is the same as 1 times 2 over 1, which is 2. 2. Then we have to say LS equals RS. If you don't say this, you will lose 0.5 on the diploma. This part here is very important. LS equals RS. Because you've just verified that the left side equals the right side. They both equal 2. Kind of make a little bit of sense? So that's what I mean. That very first step is to plug in your answer. And then your next step is to plug in your theta, or your x in the next one. And then get the answers off to the side. All right. So let's try example 2. We're trying to verify that pi over 6 works for cotan x equals cos over sine. So we have to have LS equals RS, which people choose to not write for some unknown reason. You can't choose to not write it, because that's telling you the left side and the right side. Then we have to plug pi over 6 in for that. So on the left side, I'm going to have cotan of pi over 6, which is the same as 30 degrees. But I can't put a 30 in there because I'm verifying pi over 6. I'm not verifying 30 degrees. Do we agree? Then on the right side, I have cos pi over 6 divided by sine pi over 6. Fun fact, these are going to match because that's the way we're going to find cotan anyways. So, we need cos of pi over 6, the answer. We need sine of pi over 6, the answer. And we need cotan of pi over 6. So what is cos of pi over 6? On your unit circle. Root 3 over 2 is the x at pi over 6. What's the sine pi over 6? The y. 1/2. Cotan we can't pull off for a unit circle directly, but the top two formulas are the ones we use to get tan and cotan off our unit circle. Cotan is cos divided by sine, which is technically what this verification is. So we're indirectly doing it. So we're going to get cos pi over 6 divided by sine pi over 6. Cos of pi over 6 is root 3 over 2. Divided by sine of pi over 6 is 1 over 2. They cancel and left with root 3, right? So now, for cotan pi over 6, I'm going to go equals root 3. And then this one I have to fill in. It equals root 3 over 2 divided by 1/2. These cancel and I get root 3. And now I can say LS equals RS because they do. We'll try example 3 together, and then I'll let you try the next one. So this one is a squared, so it seems a little harder. So we still have to set up our table. We have to verify this equation is true for pi over 3. So we get LS, RS. So we're going to get cotan squared pi over 3 plus 1. All cotan squared pi over 3 means is we have to find out what cotan of pi over 3 is, and then put it in here all squared, right? So we have to find out cotan of pi over 3. And then this one is cosecant squared pi over 3. So we need to find cosecant of pi over 3 and put it in. So we technically have two trig ratios we have to find off to the side. Step 1 is to plug in. Step 2 is to find out those trig ratios. So we need cotan of pi over 3. And we need cosecant of pi over 3. Cosecant of pi over 3 is easier because it's the reciprocal trig ratio of sine of pi over 3. Sine of pi over 3. What's y at pi over 3? You should go to your unit circle. Root 3 over 2. So then what is cosecant of pi over 3? 2 over root 3. And then we have to rationalize it, right? Multiply by root 3. Multiply by root 3. So we get 2 root 3 over 3. And then we have to do cotan of pi over 3, looking at our units or our formula, the top two formulas on our formula sheet. Cotan of pi over 3 is the same as cos pi over 3 divided by sine of pi over 3. What's cos at pi over 3? 1 over 2 divided by sine of pi over 3. Root 3 over 2. If the numerators cancel off, you have to leave ones behind. If the denominators cancel off, they just cancel off. So I'm left with 1 over root 3. What do I have to do with that? Rationalize. So I'm going to get root 3, and so I get root 3 over 3. Yeah? Does that make sense what we did there? So once we found that work off to the side, so we know that this is root 3 over 3. And we know that is 2 root 3 over 3. We have to plug it in. So cotan of pi squared pi over 3, that just means cotan of pi over 3, whatever the heck the answer is, that squared. That's all that means. So cotan of pi over 3 is root 3 over 3. So we're going to get equals root 3 over 3 squared plus 1. You see what I'm saying? And then we square the numerator, square the denominator. So when you square square root 3, what do you get? 3. And then when you square 3, you get 9 plus 1. 3 over 9 is a third plus 1. Then we have to change the 1 into being over 3, right? Or you could type it into your calculator. It'll give you an answer. Yes? A third plus 1 is 4 thirds. If you went from a third to 4 thirds like this, I don't care. That's good enough. Like if you know what I mean? Or from this step to this step, it's fine. You could change the 1 to 3 over 3, and then it would be 4 thirds. Yeah? Okay, then this one's cosecant pi over 3 squared. So I'm going to go 2 root 3 over 3 squared. And I'm hoping that when I do this, I end up with 4 thirds, correct? Because these should match. When they ask you to verify, they have to match. Okay, verify that it does work. It is true. So we get 2 squared, which is 4. Root 3 squared is 3. Just turn this bracket over 3. Oh, crud. I forgot to square the bottom. I was like, that's not the right answer. 4 times 3 over 9. This will be better. So I get 12 over 9, which reduces to 4 over 3. And now they match. So I get LS equals RS. So you have to substitute in first, find the trig ratios off to the side, and put their answers in. Does that make sense? Okay, we're going to flip over. One, 2, 3. Try actually 4 and 5. We'll do 6 together. It's got a double angle in it. 4 and 5, go. Okay, let's start. I thought I was recording that. That would have been scary. LS, RS. Okay, so we should have on our first step 1 plus tan squared 3 pi over 4. Secant squared 3 pi over 4. Okay, so off to the side we have to find tan is 3 pi over 4. Which is the same as what, guys? Don't all speak at once. Sine of 3 pi over 4 over cos 3 pi over 4. What's the answer to 3 pi over 4 for sine? Negative, no, negative root 2 over 2 divided by root 2 over 2, which equals negative 1. Okay, then we need secant of 3 pi over 4, which is cos flipped. What's cos of 3 pi over 4? Root 2 over 2. So it's going to be 2 over root 2. We rationalize. And we get 2 root 2 over 2. I'm just waiting because something's wrong. Negative. So it's negative root 2. This is positive, this is negative. Yeah. There we go. So we get 1 plus negative 1 squared, which is 1 plus 1 which is 2. What? Sure. We're really hoping that the other side turns to a 2. So, we're going to get negative root 2 squared, which is 2. LS equals RS. So a lot of your work should be off to the side, correct? Not within this T-table. Make sure you have LS equals RS. Does everyone have that? Because that makes you lose 0.5 if you don't have it. Okay. LS, RS. So here, we have 1 minus sine squared 210. And then we get sine 210 degrees. Make sure you have degree symbols. Cos 210. Cotan 210. Okay. Are you guys ready? Okay. Sine of 210 is what? Okay, what's cos of 210? And then we need cotan of 210, which equals cos of 210 divided by sine of 210. That was you. I don't know where you're looking. Just looking around. Who is it? It can't be me who's the one who's talking. No. Negative root 3 over 2 divided by negative 1/2 root 3. Oh wait, let's do some work here. So we're going to get 1 minus negative 1/2 squared, which equals 1 minus 1/4, which equals 3/4. Then sine of 210, negative root 3 over 2, times negative, oopsie, try again, negative 1/2, times negative root 3 over 2, times root 3 over 1. I always put it over 1 when it's fractions like this because you guys don't know whether you should distribute the root 3 to the top or the bottom. Stays on the top. So negative 1 times negative is positive. Root 3 times root 3 is 3. Over 2 times 2 is 4. LS equals RS. Boom. Shakalaka.
Wow.
We rock. These things either make you feel like you're a rock star or dumb. There's no in between. You either want to crawl under your desk and rock back and forth or be like, ooh. Yeah. You're just hucking on. Okay. Just choked on my own spit. It's a gift. You all wish you had. LS, RS. So we have tan of 7 pi over 6. And then we have 1 minus cos 2 over 1 times 7 pi over 6 over sine of 2 over 1 times 7 pi over 6. So we're actually doubling the angle there. Here's the double angle identity. We're doubling the angle. So off to the side, we'll find tan of 7 pi over 6, which equals sine of 7 pi over 6 divided by cos of 7 pi over 6. What is sine of 7 pi over 6? Writing this down, everyone? Yeah. Negative 1/2, and then cos, negative root 3 over 2. So we get 1 over root 3. Rationalize it. We get root 3 over 3. So this equals root 3 over 3. Now we have to do cos of that, sine of that. So we have to do cos of 2 over 1 times 7 pi over 6. The 2 and the 6 cancel becomes a 3. So we actually get cos of 7 pi over 3. Okay, 7 pi over 3 even on your unit circle. Is its coterminal? So go 7 pi over 3 minus 2 pi. Don't put the pi's in. Go 7 over 3 minus 2. You get pi over 3? Yeah, so it's the exact same answer, right? To pi over 3. Because remember, 7 pi over 6, or 7 pi over 3, sorry, is like going around and then coming back up here. So it ends up on that same spot as pi over 3. See what I'm saying? You took the 2 pi off of it. So this is actually the same as cos of pi over 3, which is what? A half. And then we need sine of 2 over 1 times 7 pi over 6. So it's sine of 7 pi over 3, which is the same as cos of pi over 3. That's a sine. Why did I write cos? Anyone? Familiar? Scary stuff. So it's root 3 over 2. So we're going to get 1 minus a half divided by root 3 over 2. What's 1 minus a half? 1 half. Divided by root 3 over 2. What happens with the 2's? Cancel off. I'm left with 1 over root 3. Rationalize it. Yeah? Okay, flip over. 7 and 8. 7 and 8, go. Good job. Good job. Okay, ready? Okay. Looks like Charlie only got cookies. That's okay. So we have LS, RS. We have 1 minus cos of 120 degrees over sine of 120. Which if you don't want to do these off to the side, you don't have to, because those can come right off the unit circle, right? And then we have sine of 120 degrees over 1 plus cos of 120. So, 1 minus, what's cos 120? Not all answer at once. 1 minus negative 1 over 2. And then sine is root 3 over 2. So we get 1 plus a half, which is 3 halves, over root 3 over 2. These cancel. I'm left with 3 over root 3, which I can rationalize. And then I get 3 root 3 over 3. 3's cancel, and I'm left with root 3. Then this one, sine of 120 is root 3 over 2 over 1 plus negative a half, which is root 3 over 2 over a half equals root 3. LS equals RS. Then this one, we have LS, RS, 1 over 1 plus sine of pi over 4. Secant pi over 4 minus sine of pi over 4. Secant pi over 4. all over cos of pi over 4. So sine and cos of pi over 4 are root 2 over 2. Secant of pi over 4 equals 2 over root 2, because it's the flip, equals 2 root 2 over 2, which is root 2. So we get 1 over 1 plus root 2 over 2. Let's make this a common denominator of 2 over 2 instead of a 1. So we get 1 divided by, technically, 2 root 2 over 2. 2 plus root 2. 2 plus root 2 over 2. And then we flip it and multiply, so we get 1 times 2 over 2 plus root 2. So we'll let it sit there, 2 over 2 plus root 2 for now. Then this one, we get root 2 minus root 2 over 2 times root 2 over 1 all over root 2 over 2. So fun. And we get root 2 minus 2 over 2, which is 1, all over 1, divided by root 2 over 2, which equals root 2 minus 1 over 1 times 2 over root 2, which gets me 2 root 2 minus 2 over root 2, which I can rationalize. Oh, this was really ugly. Me don't like it. 2 plus root 2. Oops, 2 minus root 2. Multiply by the conjugate. So I get 4 minus root 2. I ran out of room. 4 minus root 2 over 4 minus 2. Which equals 4 minus root 2 over 2. Then multiply this one by root 2. This is terrible. So I get 2 times root 2 is 4 minus 2 root 2 over 2. How did I get that extra 2? No, why did I get an extra 2? Oh, I have to distribute 4 minus 2 root 2. Now, could we reduce them and take a 2 out? We could, but do they match? Yeah, so stop. If you get the left side to equal the right side, like, don't go canceling them to make them prettier. Just be happy they match. Call it a day. So that's the hardest one out there. This is your homework. Now, how do you know if you're right? Left side equals right side. Okay?